All right, here are our notes for layers of the atmosphere. Okay, so first, before we talk about the layers, let's talk about the composition of the atmosphere. So atmospheric composition. So now, of course, the atmosphere is the blanket of gases surrounding the planet, and so there are two gases that make up 99% of our entire atmosphere. They are nitrogen, which has the formula N2. Nitrogen makes up pretty consistently about 78% of our atmosphere. Oxygen, formula O2, makes up about 21% of our atmosphere. And then that last 1% is made of what we call variable gases. So these are things like CH4 methane, CO2 carbon dioxide, H2O water vapor, and lots of other things, but those are kind of the three big ones that we're going to discuss in class a lot. Again, that's the last 1%. And the concentrations of these things can change a lot, but all together added up, they only equal to about 1% of our atmosphere. Okay, moving on to the actual layers of the atmosphere now. First, we have what's called the troposphere. The troposphere is the bottom layer of the atmosphere. This is where we're at. This extends from 0 kilometers, which is the ground, to 12 kilometers above the surface of the Earth. As altitude increases in the troposphere, temperature decreases. And this is mainly because the way that the troposphere is heated is because radiation from the sun strikes the surface of the Earth, heats up the surface of the Earth, and the Earth re-radiates that heat back out into the atmosphere. And so the further away you are in the troposphere, the colder it gets. So air pressure is something you can think of as like you're standing on the ground and there's a column of air above your head extending all the way up into outer space, and all of the molecules of air within that column are exerting downward pressure, and so the closer you are to the surface, the greater the air pressure. So for that reason, it's the highest in the troposphere, just because we're closest to the Earth. And it's also because almost all of the air, 75% of the actual air, is found in the troposphere. So it's much denser. There's more actual air particles present in the troposphere than there are in other layers of the atmosphere. So some important things that occur in the troposphere. Humans, this is where we are, we breathe here. We can breathe in the lower portions of the troposphere. Once you get about halfway up to the 6, 7, 8 kilometers high in the troposphere, it gets really hard for humans to breathe because the air is so thin. There are fewer molecules of oxygen up there, and so it is difficult to breathe. But humans, we live in the troposphere. Any kind of weather, so clouds, storms, precipitation, a lot of, like pretty much most of the wind, all of that is occurring in the troposphere. Also, airplane turbulence. So if you've ever ridden on an airplane and it suddenly feels like the plane is driving over a bumpy road but up in the sky, that's because the density of the troposphere makes it such that there can be pockets of warm and cold air. So when the plane goes over one of the pockets of warm air, it will kind of rise, and when it goes over the pocket of cold air, it will sink. And so that makes it feel kind of bumpy as the plane is moving through those pockets of air. And so for this reason, a lot of jetliners will go up above the troposphere into the next layer of the atmosphere where the air is much more stable. But in between the layers, there are boundaries called pauses. So the boundary between the troposphere and the next layer is called the tropopause. And so they based the layers of the atmosphere based on what temperature is doing in each layer. And so the tropopause is the point at which temperature stops decreasing the higher you go. The next layer of the atmosphere is called stratosphere. So the stratosphere extends from 12 to about 50 kilometers above the surface of the Earth. So just like I said a second ago, as altitude increases in the stratosphere, temperature actually also increases, which seems counterintuitive because we've lived our whole lives in the troposphere where it gets colder as you go up, but once you get into the stratosphere, it starts to get hotter as you go up. And the reason for this is because the stratosphere contains this gas called ozone. Which the formula is O3. So oxygen was O2 and ozone is O3. We'll call this the ozone layer because people refer to it as the ozone layer when they're talking about it. It's not just like a thin layer of gases in the atmosphere, it's just that this ozone is dispersed throughout the stratosphere. So the ozone layer, the ozone gas in the stratosphere, absorbs ultraviolet radiation. That absorption of ultraviolet radiation then causes heating of the gases of the stratosphere. So we'll talk about this a lot in future lessons, but it is important to note that ozone is absolutely vital to life on Earth. It absorbs most of the UV radiation that comes from the sun. The small amount that does make it through is what causes things like sunburn and skin cancer. And so you can imagine that if that tiny amount that does get through can be that damaging to us, imagine if all of the UV radiation coming from the sun were suddenly able to get through. If the ozone disappeared, we would be burnt by radiation very rapidly and die. So life would not be able to exist on Earth if we did not have the ozone layer. So after the stratosphere comes the boundary called, now we have the stratopause. And this is the boundary between the stratosphere and the next layer, which is called the mesosphere. So the mesosphere extends from 50 to approximately 80 kilometers. As altitude increases, so as you go up through the mesosphere, temperature starts decreasing again. So this is, I don't want to put that there. This is the coldest layer. The mesosphere is the coldest layer. The coldest temperatures that we measure in our atmosphere are found in the mesosphere. So the mesosphere plays an important role in protecting us from kind of extraterrestrial objects. So if you're thinking going from outside in, the mesosphere is the first layer where the air is thick enough, the atmosphere is thick enough that it can create friction against objects passing through. And so the mesosphere burns up meteors as they pass through so that they're not striking the Earth all the time. We'll stay with friction. These are called shooting stars, which is a terrible name because they have nothing to do with a star at all. That's just chunks of space junk that are flying through our mesosphere and getting burnt up and disintegrating before they can get down into the stratosphere and troposphere where we are. So now we had tropopause, stratopause, and now we have mesopause, which is the boundary between the mesosphere and the next layer, the thermosphere. So this is the final distinct layer of our atmosphere. So this extends from 80 to about 480 kilometers, so much taller of a layer than the previous ones have been. As altitude increases in the thermosphere, temperature increases again. So you can see that's how they came up with these layers. It's based on what is temperature doing in each of these regions. So the thermosphere is the hottest layer, but it's in quotation marks for a reason, and that is because the word temperature in science has a specific definition, and it's referring to the speed of molecules, like the kinetic energy of molecules as they are flying around. So the faster molecule is moving, the greater its temperature. Now, the molecules in the thermosphere are moving very fast because they have been absorbing, solar radiation up there. So they're moving very fast. However, the atmosphere is so sparse up there that the idea of heat Heat is like when molecules bump into stuff, they transfer some of their energy into whatever they bumped into. So that's why when air feels warm to us here down in the troposphere, it's because those molecules have higher temperature than our body, and as they bump into our body, they transfer some of their kinetic energy to our molecules, which raises the temperature of our molecules, and we feel this as being warm. Now, if you were to go outside in the thermosphere, the air is so sparse that the odds of one of those fast-moving molecules bumping into you and transferring some heat energy into you is so low that even though it's the hottest layer, the molecules are moving the fastest, it would still feel very, very cold to you, and in fact, you would freeze to death if you were outside in the thermosphere. So anyway, an interesting phenomenon that occurs in the thermosphere is that solar radiation can ionize gas molecules. So when solar radiation strikes molecules, so say you had like a molecule of oxygen, which is 2 oxygen atoms that are bonded together way up in the thermosphere. Solar radiation strikes it. If the radiation is strong enough, it can actually like break the bond between those 2 oxygen atoms, and when those bonds are broken, it's called ionization. And this process emits visible light. Okay, so this phenomenon is called the aurora, and when it occurs in the northern hemisphere, it's called the aurora borealis, and when it occurs in the southern hemisphere, it's called the aurora australis. Okay, so these typically only happen between 60 to 75 degrees north or south latitude, and this just has to do with like the thickness of the atmosphere, and just at these latitudes it happens to be that there is enough gases present in the thermosphere that this ionization can occur enough that there's enough molecules being ionized that we can see it really well. Sometimes the solar radiation will increase such that this will kind of extend further south, and so once in a while you can even see the aurora borealis, which is also called the northern lights. You can see this from where we are in Helena, which is about 47.5 north latitude, but in general it's pretty much localized within the 60 to 75 degrees north or south latitude. So then the final thing, we'll go to the back. The final, it's not really a distinct layer of the atmosphere, but we'll still talk about it. It's just called the exosphere. So there's no thermopause in between the thermosphere and the exosphere, and that's because the exosphere is not a distinct layer, but it basically extends from that 480 to about 3,000 kilometers away from the surface of the Earth. And here you can find trace amounts of our atmospheric gases. Trace gases of gases. Trace amounts of atmospheric gases are found here. So it's not like a layer of the atmosphere, but we've been able to detect some particles of our atmosphere way out at about 3,000 kilometers away from the surface of the Earth within the exosphere.